So today we're diving into a really foundational piece of tech called the Atomic Kernel. And look, this isn't just another software library. It's more like a blueprint for building digital worlds that are, fundamentally trustworthy, actually real. Let's see how that works.
Let's just start with a big question. What if you had a digital world that could never lie? Imagine a multiplayer game, or a financial system, or even a full-on metaverse, where every single event that ever happened could be perfectly replayed and proven by anyone. A world with no more frustrating desyncs, no glitches, no arguments about what actually happened.
That right there is the core promise. We're talking about creating a shared digital reality that's persistent and completely trustworthy, because it's all backed by math. You can think of it like a living simulation, one where its history is as solid and reliable as the laws of physics themselves.
Now, to really appreciate why that vision is so powerful, we kind of have to look at the cracks in our current digital foundations. Why do our big, complex systems always feel so fragile and chaotic?
Now, this is the chaos we're all living with, right? As a developer or even just a user. You've got state drift, which is just a fancy way of saying two computers in the same game slowly fall out of sync. You get those impossible-to-reproduce bugs that just disappear the moment you try to pin them down. Digital identities can be fuzzy or even faked. And maybe worst of all, a system's history, what it says happened, can be messed with, and you'd never even know. This is the mess that Atomic Kernel was built to clean up.
So how do you fix all that? Well, you don't just slap on another patch. You have to replace the very foundation it's built on. Atomic Kernel brings in a whole new set of rules, kind of like a new digital physics, that shifts us away from all that unpredictable behavior and moves us toward actual mathematical certainty.
And this slide really shows the difference. On the left, you've got the chaos of today's systems, this tangled mess where things can be totally unpredictable. But on the right, that's the Atomic Kernel promise. A clean, ordered system where the exact same inputs will always produce the exact same reality, right down to the last byte. Anyone can rerun the simulation and get the same result every single time.
Okay, so how is this even possible? Well, the secret sauce here is a concept called deterministic replay. It's a simple but really profound idea that if you have a starting point, a seed, you can perfectly recreate the entire history of events that came after. This is the engine that makes all that verification possible.
And this right here, this is the huge philosophical shift. We're moving away from a world where you have to trust that a server is telling you the truth, to a world where you can independently verify the truth for yourself. It's a massive change from trust to proof.
Okay, but how does this system actually enforce these new laws? How does it make sure its guarantees are truly unbreakable? Well, it all comes down to a three-part system of verification.
It relies on something called the verification triad. First up, you've got mathematical proofs. Think of these as the system's constitution, formally proving that the core laws are fair and deterministic. Then you have gates. These are like the bouncers at the club door, checking all incoming data and just flat-out rejecting anything that violates the Constitution. This is fail-close validation. Bad data gets stopped cold. And finally, replay locks create a cryptographic chain of history, like a tamper-proof ledger, making it obvious if anyone ever tries to change the past.
And all of this is organized into a really strict chain of command called the authority ladder. Down at the very bottom is the kernel. That's the absolute unchangeable law. Above that, you have extensions which can add new features, but they always have to obey the kernel. And way up at the top are projections, which are things like your user interface. And here's the key. They can only show you the truth. They can never, ever change it.
This is the golden rule of the whole system. What it means is that a bug in your game's UI, which is at the top layer, can never corrupt the core game data at the bottom layer. Truth only flows up, and authority can never flow down to break the law.
This same kind of verifiable logic applies to identity itself. A digital object, a thing, gets its unique identity from its actual content. That's the what. An event gets its identity from that object and its specific place in history, the when and where. And because every new event is cryptographically tied to the one before it, you get this tamper-proof append-only history. You can add to the story, but you can never ever go back and change what's already been written. It's locked in.
All right, so we have these incredibly powerful, low-level guarantees. But how do you actually get from a simple mathematical law to a rich, sprawling, interactive world? A full-blown metaverse.
Well, it's all built in layers, one on top of the other. You start with that pure mathematical kernel law. Then, the encoded runtime defines how that law gets expressed in code. After that, the distributed API defines how all the different computers in the simulation can talk to each other and verify what's happening.
And only then, once you have that shared, verifiable foundation, can you finally build the metaverse extension on top. The graphics, the game rules, the actual world you see and interact with, all while knowing it's resting on a foundation of absolute truth.
So the biggest takeaway here is that the kernel's authority is normative. What does that even mean? It means it is the Constitution. It's the law. It's not just some code that programmers hope is right. It's a set of rules that have been machine-checked and formally proven to be true.
And everything else built on top of that, including the metaverse application itself, only has advisory authority. Think about it like your web browser. It can show you a web page, but it can't change the content that's on the server. The world you see is just a window looking onto the one single, unchangeable truth defined by the kernel.
All right, let's bring this all home. We started out by talking about the absolute chaos of today's digital systems, so now let's look at the world of tomorrow that this kind of foundation actually makes possible.
I mean, this slide just says it all, doesn't it? We replace the ambiguity and the fragility of today with the rock-solid guarantees of tomorrow. State drift gets replaced with guaranteed replay. Identity forgery gets replaced by append-only identity. And all those random non-deterministic bugs, they basically become a thing of the past because the system's outputs are totally stable and predictable.
So where would you actually use this? Well, think about a financial audit trail where you absolutely need a verifiable, unchangeable history of every single transaction. Or a complex engineering pipeline where you have to guarantee the user interface can't possibly corrupt the core data. And of course, it's absolutely essential for any kind of shared world, from a massive online game to a true metaverse where every single player's computer has to agree on one single provable reality.
You know, for too long, we've been building our amazing digital worlds on foundations of sand. The Atomic Kernel offers a foundation of stone, of pure, verifiable mathematical truth. So the only real question left is, what world would you build on it?